here. Let's consider this example here where we want to solve for x. Notice that we have different bases here. So the bases are different. But if we look at this in detail, we'll see that anytime you take a positive number like positive 3 and you raise it to some power that is also positive. So we have a positive power. You take a positive number and you raise it to another positive number. Your final answer should always be a positive number. And here we have an equation where a positive base raised to a positive power equals a negative number. In fact, it's -2. So this tells us that this cannot happen. There's no way that you can take a positive number, raise it to a positive power, and end up with a negative number. So this is actually an example of an equation where there is no solution. And I'll show you what that looks like graphically. So if there was a solution, then these two functions, so if I call this equation on the left f of x and I call the equation on the right g of x, if there were a solution, then graphically we would see that those two equations intersect each other at a point, and then we would have a solution for x. But I'll show you next how the graph of these two equations actually never intersect. Therefore, there's no solution. So here, I hope that you can see in red, I've got the graph of 3 raised to the x plus 1, and then the graph that's in blue down here, that's the equation -2. And as you can see, the graph of 3 to the x plus 1 is this curve that keeps growing exponentially like that. And the constant y equals -2 is this horizontal line down here. And hopefully you can see that these two graphs never intersect each other. So again, it just confirms that there's no solution to this equation.